The Arctic Circle and Antarctica remain among the most mysterious places on the planet, each containing secrets beneath their frozen surfaces. As the ice continues to melt, it reveals new possibilities that can be striking, puzzling, or at times unsettling. For decades, research suggested that the waters beneath Antarctic ice shelves were far too cold and nutrient-poor to support anything beyond simple microbes. Climate change is now melting long-standing ice in both polar regions, uncovering discoveries that clarify pieces of human history, return objects once believed lost, and expose anomalies that challenge leading scientific theories. A recent study shared by Elon Musk disrupts long-held assumptions about survival in harsh conditions by revealing a thriving group of animals living on the sea floor, where complex life was thought to be impossible. This raises urgent questions about how far biological adaptation can go, and why this finding is reshaping scientific debate. So what exactly did the team's camera capture under the ice? The team lowered a GoPro camera and a sediment collector into the depths, but the device returned empty both times. Working in such extreme conditions made even simple tasks difficult. That evening, geologist James Smith reviewed the footage and noticed something unexpected. The video showed a long descent through 3,000 feet of bluish-green ice, which then opened into the deep ocean. Before the camera reached the light-colored seafloor sediment Smith needed for his research, a dark shape appeared. Another 1,600 feet down, the shape proved to be a boulder. The camera struck the sediment near it, then steadied and scanned the rock. What it revealed had nothing to do with geology. The team had found life. Not simple microbes, but complex organisms surviving where they should not exist. A single large boulder stood on an otherwise flat seafloor. This region normally lacks such debris, and Smith had selected this site by pure chance. Though he was not a biologist, his colleague from the British Antarctic Survey, Hugh Griffiths, was. When Griffiths viewed the footage, he recognized a film on the rock, likely made of microorganisms forming a microbial mat. Cylindrical sponges clung to the surface, while another unusual sponge and several stalked animals hung from the rock. Thin filaments, possibly from the mats or from a strange hydroid organism, covered parts of it. The nearest edge of the ice shelf, where the open ocean begins, is 160 miles from the boulder. The closest place capable of producing a food source lies hundreds of miles away, in an area with enough sunlight to support an ecosystem, and positioned so that known currents could carry nutrients to the organisms living on the rock. A United States submarine set a major record in 1958, when it traveled under the ice and became the first vessel to reach the North Pole. This achievement opened a completely new path for scientific research, giving experts access to an environment they had never been able to study closely before. Today, nuclear-powered submarines operate as silent tools of defense, able to stay at sea for long periods while carrying torpedoes and nuclear missiles. Since 1969, the UK has kept at least one nuclear-armed submarine on patrol at all times, showing how important these machines have become for national security. The mission also marked a turning point for science, helping launch a new era of exploration focused on the strange world beneath the Arctic ice. It proved the military value of nuclear submarines while also expanding scientific knowledge. Both the Navy and researchers gained a clearer understanding of the Arctic Ocean and the harsh conditions these vessels must withstand. Submarines allow access to a difficult environment that helps scientists study what is happening there now and what these regions may face in the future. Antarctica is not only the coldest continent on Earth, but also one of the places filled with the greatest number of unanswered mysteries. Beneath its ice and throughout its surrounding waters lies a collection of unusual and remarkable discoveries waiting to be found. Even though it is remote and harsh, carrying out research in Antarctica brings extreme challenges. Nothing comes easily when working on the Filchner-Ronne ice shelf. Geologist James Smith from the British Antarctic Survey spent more than 3 months there, 5 hours by air from the nearest outpost. He lived in sub-zero temperatures, slept in a tent, and relied on dehydrated food throughout the mission. Even during the southern summer, he needed to reach seafloor sediment buried under half a mile of ice to study the history of the floating shelf. The scientific work was exceptionally demanding. Smith and his team had to melt 20 tons of snow to create 20,000 liters of hot water. They sent the hot water through a pipe lowered into a borehole, slowly cutting into the ice for 20 hours before breaking through the shelf. The physical effort and careful planning required for this task were immense. Every stage needed precise preparation and steady focus in one of the toughest environments on the planet. If you enjoyed this video, give it a like so YouTube can recommend it to even more people. Tap the hype button right below if you're watching on your phone. As the distance from the open ocean and sunlight increases, life becomes increasingly scarce. This is a basic principle of marine biology. Past research beneath ice shelves has revealed small mobile scavengers and predators, such as fish, worms, jellyfish, and krill. Scientists believed that filter feeders, which rely on steady food from outside sources, would be the first to vanish as conditions grew harsher. Hugh Griffiths explains the importance of the new finding by noting that it breaks with long-standing expectations. According to existing biological theory, these organisms should not be able to survive here at all. The boulder may look ordinary, but its location and the life growing on it make it one of the most meaningful discoveries in recent Antarctic studies. How these organisms reached the site is only one of many questions. What food source supports them? How long have they lived there? How often do such boulder communities appear under the ice? Are they the same species found in open waters, or have they adapted into entirely different forms? What would happen to these communities if climate change caused the ice shelf to collapse? These creatures live in total darkness, which is not unusual for deep-sea life. But immobile animals on the seafloor depend on a constant supply of marine snow. As organisms in the water above die and sink, other animals feed on them, breaking them apart and creating tiny fragments that settle onto the seafloor. This natural cycle provides food for many bottom dwellers. This system operates across much of Antarctica, where productive waters support abundant plankton, which in turn feed fish and larger animals, such as seals. All this activity produces debris and dead organisms that fall as marine snow, forming a steady nutrient supply. But the animals on this boulder do not live beneath an active water column. They sit under a mile of ice that blocks all sunlight and prevents the usual formation of marine snow. They also cannot move from their location to seek food. Griffiths points out that being fixed in place where food is scarce and arrives unpredictably is one of the worst survival situations. How these organisms manage to feed themselves remains the central mystery. Researchers suggest that the food supporting these organisms moves sideways through currents instead of falling from above. In this region, marine snow may drift horizontally, carried from productive areas located 390 to 930 kilometers away. Even if the supply is small, organic material traveling these long distances could still reach the boulder and sustain its community. The distance involved is extraordinary. In the Challenger Deep, marine snow drops 7 miles to the seafloor. For these Antarctic animals, food may travel up to 133 times farther, moving laterally instead of vertically. Yet experts note that this idea aligns with what is known about Antarctic currents. As seawater cools, it grows denser, sinks, and spreads outward along the seafloor. Other water flows in to replace it, bringing organic matter across vast distances. These same currents may also deliver new species to the boulder, supporting reproduction and genetic variety. But without physical samples, researchers still cannot confirm the exact diet of the sponges or determine whether any are carnivorous. Some scientists point out that finding predatory sponges in such a dark and isolated place would be a remarkable discovery. The camera did not record fish or crustaceans during its short survey, leaving it unclear whether mobile animals share this habitat or prey on the sessile creatures. Key questions remain. Do all the organisms rely on the same food source, or do they share nutrients through symbiotic relationships? Are roaming species involved in supporting this colony? Only future missions with more advanced tools can answer these questions. The animals do not seem threatened by heavy sediment. The boulder appears to sit in a favorable location with enough food, minimal predation, and little risk of being buried. Ripples in the surrounding sediment, likely shaped by currents, support the idea that food arrives from afar. How these organisms first settled on the boulder is still unknown. They may have spread from nearby rocks or descended from ancestors far outside the ice shelf, carried as eggs or larvae by currents until they landed here. Without samples, scientists cannot estimate their age, but Antarctic sponges can live for centuries. The community on this rock may be extremely old, shaped over generations as new life slowly joined the colony. Christopher Maw of the Smithsonian notes that finding carnivorous sponges in such a dark and isolated place would be extraordinary. These species exist elsewhere in the deep sea, but discovering them under an ice shelf would be especially striking. Since the camera recorded no fish or crustaceans, it is still unknown whether mobile predators visit the boulder, or if the organisms there experience little or no predation. It is also unclear whether the animals share food through symbiotic relationships or rely on other roaming creatures for nutrients. Because current equipment could not answer these questions, a future mission with better sampling tools will be required. The organisms do not seem threatened by sediment burial, as the surrounding deposits are light. This favorable balance led Griffiths to describe the site as a Goldilocks situation, with enough incoming food, little predation, and minimal sediment. Ripples around the boulder, shaped by flowing currents, support the idea that nutrients travel from far away to reach the community. How the organisms first colonized the boulder is another mystery. They may have spread from nearby rocks or drifted as larvae from distant areas where typical marine ecosystems exist. Without specimens, researchers cannot determine their age. Antarctic sponges can live for centuries, so this community may be ancient, shaped by changing currents and multiple colonization events over long periods. Elon Musk, the researchers, and the broader scientific community cannot determine whether this rock represents an anomaly or if such ecosystems are typical beneath the ice. These animal populations might not have appeared by chance when the scientists positioned their cameras on the rock. Perhaps they represent a common sight on the seafloor beneath Antarctica's ice shelves, hidden from view simply because no one has looked in the right places. There would certainly be ample space for such ecosystems throughout the 560,000 square kilometers of these floating ice shelves. However, only a space the size of a tennis court has been examined beneath them by scientists using earlier boreholes. The explored area represents an infinitesimally small fraction of the total area. It is entirely possible that these communities are numerous, and researchers simply have not yet located them due to the immense logistical challenges of accessing these environments. This represents the first recorded account of a hard substrate community, specifically a boulder community, deep beneath an ice shelf. The discovery seems to defy all prior hypotheses regarding the kinds of life that would be able to endure in such extreme conditions. The researchers estimate that this colony could be up to 1,500 kilometers upstream from the nearest source of photosynthesis based on the local water currents. This distance is unprecedented for sessile filter-feeding organisms. However, until the researchers have the equipment to gather samples of these species, a monumental challenge in itself, they will not know more about these animals. The technical difficulties of returning to this site with sampling equipment are staggering. The location is remote, the drilling process is time-consuming and expensive, and the window of opportunity during the Antarctic summer is limited. Other organisms are also known to acquire nutrients from glacial melts or compounds from methane seeps, so alternative food sources beyond horizontal marine snow transport remain possible. Humans have lived in the Arctic for thousands of years, yet much about the region remains unknown. It is far easier to reach than Antarctica, so it has been explored more extensively, but major questions still surround what lies beneath its ice and cold waters. In 2018, NASA scientists flew over the Beaufort Sea during Operation Icebridge, a yearly survey of shrinking polar ice. During the mission, they discovered 3 circular ice formations unlike any seen before. The circles were nearly perfect and did not match known natural patterns, leaving researchers unsure of their origin. One leading explanation is that ringed seals created the holes. These seals can hold their breath for long periods and often claw openings in the ice to breathe. Such holes are common across the Arctic, but none had been observed in this specific area, hinting that the ice there may have thinned. Seals overall do not appear to be in sharp decline despite warming waters. Leopard seals can even adapt to milder climates, as shown by one individual, Oha, who traveled from Antarctica to New Zealand. Other theories suggest the circles may result from seals surfacing, ice sheets pressing together, or geological activity. Some NASA experts believe warm springs may be breaking through the ice due to rising ocean temperatures. Scientists still cannot determine the exact cause. Without Operation Icebridge, the formations might never have been detected. Whether they are linked to seal behavior, shifting ice, or geological forces, the mystery highlights how much remains unknown in the Arctic. Strange geological formations have been discovered in the Arctic before, some appearing almost impossibly regular. Photos from 2003 show dozens of perfectly formed rock formations in the area, including what appear to be circles arranged in patterns. The formations look so regular that they seem artificial. Who or what fashioned them? Surely natural processes cannot produce a sequence of perfectly circular shapes arranged in such an orderly fashion, or can they? The ground has frozen and thawed repeatedly over thousands of years, creating intricate patterns that are sometimes mistaken for human handiwork, or even messages from ancient civilizations. Remarkably, humans can look at such things and infer that they were created by an intelligent mind. The tendency to see design and purpose in natural formations runs deep in human psychology. Some observers have concluded that these are messages left by ancient people that have persisted for millennia, waiting to be decoded. Strange appearances were often caused by Earth's own geology, rather than any intelligent intervention. Similar phenomena have been seen all over the world, from the Arctic to Australia and Kenya. All are part of a phenomenon dubbed patterned ground, and all are caused by various natural mechanisms. The freeze-thaw cycle, combined with the movement of rocks and soil, creates remarkably regular geometric patterns. Similar patterns have also been observed on Mars's surface, where no human has ever set foot, providing strong evidence for natural geological processes. In a broader sense, it seems to be human nature to attribute significance to innocuous natural phenomena. The tendency to see patterns and assign meaning to them served evolutionary purposes, helping ancestors identify threats and opportunities. However, this same tendency can lead to seeing design where none exists. The Giant's Causeway in Northern Ireland represents another fascinating natural landmark due to its coastline filled with hexagonal basalt columns. The formations are so regular and geometric that they appear artificial. Legend has it that a giant created the causeway so he could travel to Scotland and settle a score with another giant who lived there. The mythology surrounding the site is rich and detailed, passed down through generations. Although the columns may look out of the ordinary and seem impossibly regular, they were actually formed naturally by volcanic activity many centuries ago. As lava cooled and contracted, it fractured into these remarkably uniform hexagonal columns, demonstrating how natural processes can create seemingly impossible geometric perfection. Recent discoveries in the Arctic and Antarctic have been striking and unsettling. Rapid melting of the polar ice caps, driven by global warming, has been documented for years. Each summer, Arctic glaciers retreat further, and ice that took millennia to form disappears within decades. As temperatures rise, long-frozen microbes are re-emerging from melting ice. In 2016, a sudden anthrax outbreak in a remote Siberian region hospitalized 72 people. The source was groundwater contaminated by bacteria released from a thawing reindeer carcass that had been frozen for decades. In Norway, 6 young men who died during the 1918 Spanish flu were found in a state of near-perfect preservation, with viral material still present in their blood. Experts also warn that smallpox, eradicated in 1980, could reappear if graves frozen in Arctic permafrost thaw and release the virus. These findings raise serious concerns. As warming continues, more ancient biological material will be exposed. Scientists cannot predict which pathogens may emerge or how dangerous they might be to modern populations with no immunity to diseases from the past. The melting ice is not only a threat to ecosystems and sea levels, but may also pose a significant public health risk. An even more astonishing discovery emerged when scientists drilled deep into the Earth, uncovering entire hidden ecosystems that should never have existed within an underground river beneath the Larsen Ice Shelf. The hidden chamber sits about 1,640 feet below the surface. Scientists were led to the site after noticing an unusual groove in satellite images, but they did not expect to find life in such isolation. When the team reached the chamber, they found tens of thousands of small amphipod crustaceans thriving in total darkness, a discovery that stunned researchers and revealed an ecosystem functioning independently from the surface world. A new map of the Southern Ocean has also given scientists their most detailed view of Antarctica's seafloor, including the Factorian Deep, discovered in 2019. This deep point lies nearly 24,400 feet below the surface, an extreme environment equal in depth to 17 stacked Empire State Buildings. Until recently, little was known about how the Factorian Deep connected with the surrounding seafloor or influenced ocean circulation. The updated map, created from more than 1,200 sonar datasets and covering over 18.5 million square miles, helps scientists identify seamounts and potential biodiversity hotspots. Detailed seafloor mapping is essential for understanding ocean currents, nutrient flow, and possible ecosystems. Because the Southern Ocean plays a major role in global climate, this information helps researchers predict future environmental changes. Yet time to study these systems may be limited. Even ecosystems hidden beneath thick ice are threatened by global warming, and collapsing ice shelves could erase communities that may have existed for thousands of years. Thwaites Glacier, known as the Doomsday Glacier, is already showing alarming signs of instability. Underwater robots have revealed that it is barely anchored to the seafloor. Once it detaches, its rapid movement and accelerating ice loss could trigger collapse sooner than expected, raising global sea levels by several feet. Recent mapping shows parallel grooves the glacier carved into the seafloor in past centuries, evidence of earlier episodes of swift retreat. Scientists warn that with rising temperatures, another period of rapid melting may now be approaching. The Navy's discovery beneath the Arctic ice, revealed by Elon Musk, represents far more than a simple biological curiosity. The thriving ecosystem on a boulder beneath half a mile of ice, sustained by nutrients traveling hundreds of kilometers through ocean currents, fundamentally challenges scientific understanding of where and how complex life can exist. The organisms living in complete darkness, in near-freezing temperatures, isolated from typical food sources, demonstrate that life's adaptability exceeds even the most optimistic predictions. The research continues, driven by scientists who endure extraordinary hardships to advance human knowledge. Future expeditions will return to the boulder with equipment to collect samples, analyze the organism's genetics and physiology, and understand how this impossible ecosystem functions. The answers will inform not just biology and ecology, but also astrobiology, climate science, and the search for life beyond Earth. What aspects of this discovery are most fascinating? The organisms surviving in complete darkness, the horizontal transport of nutrients over hundreds of kilometers, or the implications for life on icy moons like Europa. Share thoughts in the comments below. If you enjoyed today's video, don't forget to hit like, subscribe, and turn on the notification bell so you won't miss our upcoming journeys. And if you enjoy discovering interesting things that Elon Musk reveals, check out my video of Elon Musk revealing a terrifying NASA discovery on Mars, where discoveries like pure sulfur crystals, contrary to predictions, isotopic clues about catastrophic climate change, and organic molecules resembling fragments of ancient cells are unveiled. Click on the card shown on the screen now. Enjoy the video. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.